This is the clean room where we do our LCD development. We make displays in here which are up to 6-inch size. And there's lots of things you need to do when you make a test display. Lots of different layers you need to do, but essentially what it is a sandwich. So you've got 2 layers of glass, they're your slices of bread, and in between you've got your filling, which is a layer of liquid crystal. You think of your liquid crystal as being a sort of soup of little matchsticks, tiny matchsticks, molecule sized. And one of the things you need to do is get those matchsticks to line up. You need to tell them which way to point. And the way that we do that is a very long established way of doing it. We rub the glass. Actually, strictly what we do is we put a very thin layer of a polymer onto the glass first, extremely thin, only a few atoms thick, and then we rub that. And when I say we rub it, we literally get some cloth and we rub the polymer. And then when we put our liquid crystal, our soup of matchsticks on top of that, those matchsticks align with the direction that we've rubbed the polymer. Now, how does it work? No one really knows. There's been lots of theories over the years. Maybe we're putting tiny scratches into the surface of the polymer. Another theory is that maybe we locally almost melt the polymer as we rub it and sort of tease the polymer chains out. But no one really knows. Nevertheless, it works. That's what we do. Although I should add that actually rubbing is one of those things you don't actually like doing. If you work in clean rooms like we do, rubbing things with bits of cloth is actually a necessary evil in some cases. It generates dust. One of the reasons actually Sharp has moved on from traditional rubbing, at least in some of its production lines, and it's developed a process called UV²A, where instead of using a cloth for rubbing, we actually rub with light. How it's done is very confidential within the company, but it's a process that Sharp's developed to make its displays even better.